In this part of the course, we will learn more SQL commands that we can use to manipulate data that we have in the database. So there are a couple of videos, that you can watch, and some SQL also videos that would be nice to watch if you need more information than I gave you in this video. So the language that we've been using to talk to the database is called SQL, and SQL stands for Structured Query Language. It is the database language that's designed to manage the data that is in the relational database. Now, where did SQL come from? It started in the 1970s by IBM, and they developed it so that they can manipulate the data that they were storing in their database management system. And at that time, it wasn't called SQL, it was called SQL. SQL stood for Structured English Query Language. And you will find a lot of people right now, if you watch like videos on YouTube or like professors in college, you will find a lot of people that say SQL instead of SQL. And the reason they're using SQL is because that was the name that was given to the language when it was developed by IBM. Later, Oracle incorporated SQL, took over and did the implementation of the SQL that we're using right now. Why do we need the SQL database language? A couple of things. We need to create the database and the tables. So when we're creating the tables, we used SQL commands. When we wanted to add data or delete data or modify data or query data, we use the SQL for all that. Now, when you talk about SQL, it's broken up into several kinds of commands. So the commands that deal with creating the database tables and dropping the database and doing basically the database itself, manipulating it, and some of these commands that you see in the box, we'll actually talk about them in this chapter. But these commands that deal with the creation of the database tables is called the DDL, the data definition language. You are defining the database. And then there is the data manipulation language, the DML, and that is for manipulating data. So DDL is to create the structure that you're going to be using, and DML are the commands that deal with inserting data and deleting data. So if I want to insert a row or delete a row, that's in the DML. Also part of the manipulation is the query language, the queries that we run, like the select commands, for example. And then there's DCL and TCL, which we are not going to cover in this part of the course. So DCL deals with granting access and rights to people. Remember, one of the advantages of database management systems was that you can restrict who gets access to the data. So for me, for example, as an instructor, I'm not able to get access to your financial aid information. So granting privileges or revoking privileges, that's part of the DCL of SQL, which is the data control language, controlling access. And then there's TCL, which is transaction control language, making sure that the transactions that happen are complete. So if someone starts making changes, they've committed their changes and they've actually saved them to the database. So we cover DDL. We've covered some of the commands of DDL. We will learn a few in this chapter, and we've covered DML. So the first command that we're going to add, it's not a command, it's part of the create table command, is the check constraint. So we learned to create constraints, the foreign language constraints, and the primary key constraints. But there are other constraints that we can use. So the check command is a nice command that you can use next to a column to make sure that the data in this column is within a certain range or follows a certain structure. So the best way to learn what this does is to look at some examples. So here I have a table. Here I have a table called persons, and I'm storing information about some people. So I'm storing their, their unique ID, their last name, their first name. And here, by saying that PID is an int, this was one of the ways that I made sure that the data was valid by limiting the data structure, the data that can be stored, by identifying the data type. Last name also, I'm able to select what type of data it is that gets stored. one of the constraints that we learned we can use is not null, to make sure that, whenever someone is inserting data into the persons table, they actually save data in there. And then here I'm requiring that the last name not be null. We also learned the unique keyword, which is not shown here. But if you have a column and you want to make sure it's unique, you can set the constraint for it to be unique. Now, the constraint, the check keyword, it's also a type of constraint. And what you do is you come next to the column after you've defined the data type for it, and you use check. And then in parentheses, you say what you want to check. So for example, if I'm doing like a table where I'm hiring people and I want to make sure that their age is greater than or equal to 18, they're 18 or older, I can say check age greater than or equal to 18. So if someone tries to insert a person that has an age that's less than 18, the insert command will fail with a constraint error. Okay. You could do the constraint check on the same line as the attribute, the column, okay? Or you can do it on its individual line, like as a table constraint, just like we learned to do with primary keys and foreign keys. So if you do it at the table level, you can say constraint, you can give it a name, and then you use check, and then it would be the same thing. Check age is greater than or equal to 18. Here, because the age is already mentioned inside the parameters, inside the parentheses, you don't have to list it anywhere else. So this is how you would add a constraint, for example, for age. Let's look at another example. Here, I want to add two constraints. I want to make sure that the age is greater than or equal to 18 and the person is from Manchester. For example, they live in Manchester. So I could have done it with two constraints. I could have added a check, age greater than or equal to 18 on the age line, and another check on the city for it to be equal to Manchester. So I could have added two attribute checks. But I can also do it as one table constraint, and I do the check inside, and I can use the word and. So we can use the words and, or, just like we did learn before. Here is an example with the or. I have a table, and I want to make sure that either they're hired after 2010 or their salary is greater than 5,000. So we can use the ands and ors with the check command. And notice here that I do have a check command on the age attribute. So these are independent. It's okay. You can have them at the table level, you can have it at the attribute level, or you can have it at both. Okay. Now, with the PID, like the banner ID, for example, at here at MCC, the banner ID always has to start with the @ symbol, right? And so I can use the like keyword, for example, to say I want to make sure that the PID looks like @ and then followed by any number of characters. So remember, the % sign would match any number of characters. If I knew how many it has, let me just, so here, if I know how many it has, I can use the underscore. So remember, the underscore will match exactly one character. So here it is matching @ with any number of characters after it. Here I'm matching the @ with 9 digits. So here I have 9 underscores that I've used. And you could do this for anything. Like, for example, here is an example with the social security number where I'm saying the social security number has to be 3 characters and then the dash and then 3 characters, a dash, and then the 3 characters. So the check constraint is nice so that you can make sure that the data that's being inserted is correct. So we're maintaining the integrity of the data. Okay. Another command that we're going to talk about is the alter table. Sometimes you create a table and then you decide later, I need to modify this table. And if there is data already inserted into the table, you don't want to be deleting all the data, dropping the data, recreating the data, and then reinserting the data. You want to modify the data that already exists. So the alter table command does that for you. So the syntax for it is alter table, and you put the name of the table, and then what is it that you want to alter? So for example, let's say I have a table and I want to add some commands, columns to it. I can say add column. If I want to drop a column, I can say drop column. So here I have a person's table and I want to add the email, another column. Okay. or I want to add more. If I want to add more, I can put them in parentheses, and then I can drop. So let me pause at this point and let's go to SQL Developer and try some of these commands that I've been showing you. So here, let's create a table, and I'm just going to say sample at this point. And let's have it have an ID. Let's call it ID, and it's an int. And let's say this is the primary key. And then I have, for example, a color, which is the varchar 2, and let's say it's 10 characters. And let's add one more column, which is the price, and let's make it an int, or let's make it a number. Make it 2. Okay. And here I want to add a check, so I want to make sure that the price is greater than 0, and I don't want it to be too expensive, so I want to make sure that the price is also less than 20. Okay, so here I'm creating a table. Oops, I forgot the word table. Let's create this table. Okay, now I want to alter it. I decided that I need to add more information. Let's insert something first into the table. So insert into sample values, and let's insert 1 is blue. Oops, single quote, blue, and it is $9. And let's do another insert into sample values 2, and it's also blue, and $10. And I'm just going to insert one more because I want to show you something later that we'll need a lot of data for. 3, 4, 5, and let's make some of them red. And let's make this one 8. And this one I'm going to make it 25 to see that error message that I'm going to get when I insert. So let's insert the 4 good ones first. Okay, and then when I try to insert the bad one, it's going to give me a check constraint system violated. Now, because I didn't name this constraint, I'm getting this weird name for my constraint. Okay, so this one is bad. Let's change it to just be 8. Okay, let's just insert it. Okay, so now I've inserted the data. Now I want to alter the table. So what I want to do is I want to alter table sample. I want to make a change to it. And the change I want to do is I want to add, let's add 2 columns. So let's add store char 2. Let's make it 30. And I want to add, let's add a city. 2, also 30. So here I am adding 2 tables. And do I have anything wrong with it? I don't see anything wrong. Oh, I forgot one more parenthesis. Okay, so here I'm altering the data. So let's see what the data looks like first. So select star from sample. So here the data will show me at the columns that I have, which are 3 columns. Okay, and then I'm altering the table to add 2 more columns. And it tells me that it's altered. And then when I look at the data, I will see that the table has been altered, 2 columns have been added, and because I'm adding new data, it just set to null. Okay, now let's say I wanted to drop a column. So after altering it, I want to drop a column. You can also use the alter command to do that. So I can say alter table sample, and I can say drop, for example, the city. So let's drop the city. Okay, and now if I look at my sample table, I will find that the city column has been deleted. So no more city table. So this is nice because you can alter a table that already exists. If there is, even if that column had information in it, you would still be able to drop it. So if I wanted to drop the price, for example, I would still be able to do that. Okay, so these are some samples, examples. Another command that you can do, so we can add, we can drop, we can also modify a column data type. Now, if you want to modify a column, remember, you're changing the data type of the column. That means the data that's in it might be invalid. And so when you modify a column, that column must be empty. So here, if I want to modify the store, instead of being a varchar 2, let's say it's going to be the store ID. It needs to be a number. I can do that because the store is empty. So I can come and say alter table sample, and then I can say modify store to be an int. Okay, so that will let me do it. No problem. But if I try doing that with another, so here it's fine. Now let's try alter table sample, and this time I'm going to modify the color to be an int. I can't do that because color already has data in it. And so if I try to alter the table, it complains and says column to be modified must be empty to change the data type. So this one is invalid. I am stuck now at how to do the comment. Sorry, too many programming languages. So this one is invalid. Okay. Another thing you can do is rename a column. You can change the column. If you don't like the column name, you can change it. So after I changed the sample, the store, sorry, to be an int, I can alter it so that instead of being called store, it's going to be called store ID. Sorry, so not rename, not modify, rename store to store ID. Rename column. And so now if I try looking at the data inside the table, I will see that the column got changed to store ID.